Welcome to the class, dear students. In today's lecture, I am going to explain that any square matrix can be expressed as the sum of a symmetric matrix and a skew symmetric matrix. What do you mean by a symmetric matrix? You know already. Whenever the matrix can be equal to the transpose of this matrix, then we say that it is a symmetric matrix. And a matrix, if it is equal to the negative of the transpose, then it is a skew symmetric matrix. That you know already. So let us take an example now. Any square matrix you can, in fact, I am just randomly writing one matrix. Let us say A is equal to 1, 0, minus 1, 2, 1, and 3, 2, let us say some minus 3. So this is the matrix A. So let us now write down what is the symmetric matrix first of all. How to find out the symmetric matrix. So to find the symmetric matrix, what we do, we write down the matrix as A as S is equal to half of the matrix A plus its a transpose. So let us see what is this now. That is half of. Now the matrix is what? 2, 1, 0. Minus 1, 2, 1. And 3, 2, minus 3. So let us write down the sum of with the transpose. The transpose is the first row becomes the first column. Second row becomes the second column. Third row is the third column. So this is what your matrix. Okay. Done. So now what is the matrix? S is given by half of. Let us sum the matrices. Now the element 2 plus 2, which is 4. So like that you have to add the matrices. 1 minus 1 is 0. 0 plus 3 is 3. And minus 1 plus 1 is 0. 2 plus 2 is 4. 1 plus 2 is 3. 3 plus 0 is 3. 2 plus 1 is 3. Minus 3 minus 3 is minus 6. This is your symmetric matrix. Let us now find out the skew symmetric matrix. Let us call this as K, and this is half of A minus A transpose. So that gives you half of. Now the matrix is 2, 1, 0, minus 1, 2, 1, 3, 2, minus 3, minus the transpose, which is 2, 1, 0, minus 1, 2, 1, 3, 2, minus 3. So this is what you are going to find out, this skew symmetric matrix. Let us see what is this now. This is half of, now 2 minus 2, that is 0. So 0, 1 plus 1 is 2, 0 minus 3 is minus 3, minus 1 is minus 2, 2 minus 2 is 0, 1 minus 2 is minus 1, 3 minus 0 is 3, 2 minus 1 is 1, minus 3 plus 3, it becomes 0. This is your skew symmetric matrix K. Now what we are going to write is A is the symmetric matrix plus the skew symmetric matrix. So what is that now? That is half of. Now the symmetric matrix, what we have got it here is 4, 0, 3, 0, 4, 3, 3, 3, minus 6 plus. Anyhow, half is common. We do like this. This is 0, 2, minus 3, minus 2, 0, minus 1, 3, 1, 0. So let us add these two now. What we get is the original matrix A itself. So therefore the skew matrix. So half of 4 by 2, which is giving you 2. Correct? Your first entry is 2 here. And now that gives you, let me rewrite this one. 4 plus 0 is 4 by 2 is 2. And 0 plus 2 is 2 by 2 is 1. And 3 minus 3 is 0 by 2 is 0. And then 0 minus 2 by 2 is minus 1. And then 4 by 2 is 2. And then 3 minus 1 is 2 by 2 is 1. And then 3 plus 3 6 by 2 is 3. And then 3 plus 1 4 by 2 is 2. Minus 6 by 2 is minus 3. So just verify that is this not the same matrix A which was given in the beginning? Yes. So you can, now this matrix I have written just randomly, and we are able to write down that this matrix is the sum of the symmetric matrix and the skew symmetric matrix. Is that clear? And I hope you could understand what is the skew symmetric matrix here. So you understood that the row has become the negative of the column. So A is equal to A transpose here. That's what happened. Yes, I hope you enjoyed it. Thank you.